I hate interrupting conversations and all, but we got to get started. All right, beep beep goes my phone. All right, are we live there? We're live. All right. Welcome to this meeting of the Warren Astronomical Society. We are live at Cranbrook Institute of Science. So I'm the president, Bob Tremblay, and I can't believe it's February already. So, do we have any first-time attendees? We do have some. Oh, get out of here. We have some old timers that showed up again. So yay. So no first timers. So where'd you hear about us? I don't have a gavel. You know what? We used to have Brian, and that's a sad thing. Sigh. So as a tradition, one of the things we like to do here is go around the ranks of the audience. Introduce yourself. So hi, I'm the president, Bob Tremblay.
Publications. University Crater. You're a Ross visitor. All right, so on. I don't learn first vice president. Charles Frank, my secretary. Brian was that.
Elon Parker.
Jonathan Kade, absolutely not.
All right. So thank you, audience. So some announcements. I found out from a Facebook post from Cranbrook that Brother Guy is going to be here March 17th. And what's funny is he hasn't even mentioned that to me yet. So yeah, so I'll be talking to him tomorrow about that. So oh, no, no. So I don't know if there's any calendars left. There are still watch calendars. $15 available here. Watch wearables and merchandise is available from Marquette's here over there. You can see what is available in our wonderful newsletter. Uh, if you haven't figured out what you're going to do, start figuring that out soon. My plan to go to Austin has fallen through because I want my granddaughter to see it. So now I don't know what I'm doing. So I need to figure that out. I'll be talking to people at the break about it. So we have the keys to the at Stargate Observatory. Finally, I brought a couple things to post in there. But if you have any ideas for things to post in our message board, maybe change to monthly sky or whatever, if you'd like to take that over, we'd love that too. So officers report. So we need suggestions for the banquet for somebody to uh, take the money in and do the raffle and that kind of stuff. We want to relieve Dale Teamy from that position next year so he can actually enjoy the banquet. So I'll be bringing that up in the fall when we start talking about the banquet. But if you have any ideas, let me know. So I was at the Cranbrook meeting. Sorry, uh, but I was in Tucson at a workshop being hosted by the Vatican Observatory. And wow, it was really cool. I arrived a few days early, so I got to spend some time with Brother Guy, and we had a couple of walks, which I've never done with him before. So that was really, really cool. Um, Saturday, he had right before he started, he said, "Hey, newsletter, remember the program book you made for one of these? Yeah, can you do that again in 2 hours?" Like, sure, no problem. So I got it done. We walked it up to the print shop. So we one of the days we took a trip to the University of Arizona's Mirror Lab where they spin cast up to 8 meter mirrors. They did that in Observatory's mirror. It was their first. It was like 1.9. But the giant Magellan telescope is going to have what 7 or 8 of these 8 meter mirrors. So it's very, very cool. Then we went to the Kuiper Science Building. I can't remember the right name of it, but that was awesome. They had racks and racks and racks of old observation data from Mars and Venus and models and globes. And I was just want to take all this home. They wouldn't let me. But we then Connie the next day, Connie gave a presentation and was talking about her teaching her experience teaching astronomy and science. And then observatory board member Larry Lebowski, who just became an American Astronomical Society fellow last week, he gave a presentation, a meteorite lab that was really, really cool. And then we went up to Mount Lemmon. I got to see a bunch of historic telescopes and the Causland telescope, which was just awesome for me. So Dale's probably wondering why I'm not doing it. I will. I'll probably do a presentation on this because this workshop was really, really cool and we did a whole lot. So speaking of which, got a report, Dale? This is our first vice president, Dale Parton.
Hello, everyone. Just to say, don't be shy. If you have an idea or something you could present on, let me know. We can discuss it. We can schedule it whenever you want. I've got openings for a long presentation starting in July and for short presentations in May. But if you need more time, that's okay. Just let me know. Thank you.
All right, is Riyadh online? Riyadh is not online. Yes. Oh, he is right there. Hi, Riyadh. Can you give
Hi.
us a report on the observatory? Hi there.
Yeah, sure. Hello, everyone. Yeah, we had a meeting. Our last, first actually open house was on the 27th of January. We met. There were four members, or actually four public people that showed up. So no members. It was pretty cloudy, so I was out there. We were open for about a little over 2 hours. Um, so the next open house is on the 24th of February. And who knows, maybe we'll have clear skies. Come on out anyways. A lot of times we just kind of sit down and chit chat and talk about astronomy anyhow, or the observatory, or so maybe we'll see everyone on the 24th. Thank you.
All right, thanks, Riyadh. All right, treasurer David.
So, treasury report, so most recent bank statement that we got, our account shows that we have $25,219.01. This is the first since January, it's been about going to microphones online. Here you.
Right. So again, the bank account shows $25,218.01. So some things that have occurred since January. We started the process to transfer the account from past board members to myself and Bob. Yeah, what a task. We're in the process of also canceling past credit cards and issuance of new ones. We've also deposited a lot of cash that was in the cash box. So that really helped on our account. Also, some other things have occurred. We've gotten a lot of letters for renewals. We got some tonight. All those checks are being cashed, deposited, and ledger and memberships are being updated on our spreadsheets. So that's happening. And so thanks to Bob, thanks to Adrian for all the help with doing that on the account. And and that's it.
Yeah, we still have to get them something else that came in. They wanted a letter of authorization. So what a process. My goodness. So, Charlie, anything to say other than the well, you were having internet problems, so we need to talk with you about getting some notes on that board.
Hey everyone, my name's Charlie Strackbite and I'm the secretary of this fine society. And if you hadn't known, the last few nights have been fabulous for stargazing with some clear skies. And looks like we have a lot of darkness coming up, but maybe even a lot of cloudiness, right? right? At the end of the week.
It is Michigan.
I know this isn't much of the secretary's report, but I feel like I should report on these things anyways. So everybody keep an eye out for clear skies and dark skies. Thank you.
All right, Jeff McLeod, outreach. Yeah, so I got another note from anybody staying here? Quick lunch, yeah.
Is anybody staying here? Do you know what we're talking about for the eclipse? Is it? Yeah, is it, I'm waiting for a hand to go up to publicly shame you. Okay, everyone's going away, yes? Good. Okay. It's my only job as outreach coordinator to make sure that nothing happens in Michigan in early April. No, nothing came through so far for February. Mark's got some stuff on the books for March. If you do anything and you want it listed, like you do something on behalf of the club, email me and then I'll put it in my report. If you're interested in getting stuff through me, I'll let you know when I have something. But right now, no real requests coming down the line. And then I wanted to say something about something else, but now I can't remember what it is. No, not that. The simulator is currently only half mounted to the trailer, so I have a lot of work to do before the season actually starts. Stargate? Something? Yeah, all right. I'll get with you guys at the break if you need me.
Thanks, Jeff. And publications. Your task is real easy tonight. Yeah.
So, hello, WASP is online. That's all I got.
So anyway, our Stargate Observatory has this message board on the side of it. We haven't gotten the key in forever. We just got the key, so we got to start putting stuff in it, like announcing like who we are, what this is, how to contact us, that kind of thing. So our newsletter is up. If you haven't seen it, you should. It's awesome. If you need to contact the board for any reason, you can contact us via email at board@warrenastro.org. Some astronomy in the news. One of the more interesting things I saw recently is somebody reprocessed Voyager 2 images of Uranus and Neptune, and they color corrected for some, I don't even know why, but Neptune apparently looks a lot like Uranus now, and Uranus is actually a little lighter. I'm getting a boo over here. Wow. Pardon me? Yeah, actually.
And instead you could see it as crimson blue, you just never proven wrong. Right.
You look like Neptune recolor, I think. That should find it. But yeah, so the image I have here, we color both Uranus and Neptune. Uranus is just a little lighter, and Neptune is what Uranus looked like. So, yep, there it is. It's too blue, damn it. So yeah, that's causing a lot of rancor apparently amongst the astronomers in the ranks. Okay, can we get back to the Zoom session? So and in my newsletter article, I talked about these jumbos, these Jupiter-sized binary objects that they've discovered in a bunch of them in the Orion Nebula. I found the paper, and these things are anywhere between, I believe, 0.7 and 13 Jupiter masses, and they are separated like 30 something to 340 something AU away from each other. So they're very far away from each other. So that was an interesting tidbit on that. All right. So special interest group, and our first one is going to be David Levy. Still there? Take it away, David.
Well, thank you very much, Bob. I'm sorry that we couldn't get together when you were in Tucson. I wanted to. I was hoping
I had
we could next time.
I had no idea you were there for some reason, and brother guy kept me really busy.
And Brother Guy kept you busy, but he's a very interesting man. Anyway, Bob, I will be on April the 8th in South Texas, very close to the Mexican border, with Explore Scientific to see the eclipse. So I hope we'll have a clear day there. Anyway, Saturday I attended a event that Astronomy Magazine was putting up, and it was a lot of fun. The lectures were really pretty good, except mine that was there. But anyway, at the end they were all out observing, and there was this guy with a telescope who wouldn't be quiet. He just kept on a long monologue talking about this and talking about that. And finally he looked up, I walked away from him and I looked up at the sky and I saw this beautiful International Space Station making an overhead pass. And this guy, for all of his talking, didn't mention a word about the ISS passing overhead. So my poem tonight is going to be dedicated to him. It's Walt Whitman's beautiful poem, When I Heard the Learned Astronomer. When I heard the learned astronomer, when the proofs, the figures were ranged in columns before me, when I was shown the charts and diagrams to add, divide, and measure them, when I sitting heard the astronomer where he lectured with much applause in the lecture room, how soon unaccountable I became tired and sick, till rising and gliding out, I wandered off by myself in the mystical and moist night air, and from time to time looked up in perfect silence at the stars. Thank you very much, Bob, and back to you.
Thank you, David. All right, so so I get to do solar. All right, I'm going to share my screen. I've said numerous times before that the solar alerts on this thing, it's still vibrating off my desk. I was telling my wife and my mother-in-law were talking about this. I'm going to be sharing the Solar Dynamics Observatory. Let's see that thing, maybe. Share. Yeah, there we go. All right, so this is the Solar Dynamics Observatory site. It has images of the sun like the last 15 minutes in multiple frequencies. There is the photosphere, and as you can see, there is a lot going on there. There is the corona in that's ultraviolet and another frequency, but lots of sunspots. And the one over on the left there is rotating into view, and that's gigantic. So yeah, the sun's very active right now. So Riyadh, it was cloudy. Did you get to see any double stars when you were at Stargate or anything like that? Did you observe anything at all?
No, unfortunately, the clouds were too thick. But one comment about the color for Uranus and Neptune, should we not believe our own eyes? Because we do see color difference between them when we look through a telescope. Anyway.
I think we're going to have something to talk about at the lunch break. This is the snack break. This is interesting. Pardon me?
Could it be, Riyadh and others, that the reason you can see a bluish color on Uranus and not so much on Neptune is because Neptune is farther out and dimmer, and the dimmer it gets, the less we can have color sensitivity in our eyes.
Maybe, but we do see a difference between them.
I mean, but my comment is as light gets very dim, we cannot see color.
It's
We can
not
only
that
see
dim.
shades of gray.
Yeah, but
Well,
it's not that dim. We do see color. You could use even the 22-inch. You'll see the difference. We'll test for it with the 22-inch this year.
get some images and a spectra of it. Yeah, let's do some visual proof of it. Awesome.
5.6, 5.7, that's really bright.
Okay, when I've seen Uranus, it was exactly the color I expected it to be through a telescope. I can't say I've seen Neptune through a telescope. Yes, different eyes say different eyes see different things is one of the comments. All right, so any observing reports at all? Anybody see anything interesting other than clouds? Come on up, Bob. Pardon me, you is it online? Can we get to it? Sure. Right there. Pardon me? Yeah, actually, we should set something up for you to do that. That'd be awesome because back when we were doing this online only, people were posting this, or showing us a lot more stuff. If you have to do it 3 times. Okay. What I want is let's see. Here. Yeah, this was this is the Valentine's Day picture I took. This was appropriate. This was whoops. That yeah, that one there. Share. There we go. And that was taken from my patio at 25 Mile Road and Hayes, Saturday night. So that's about a Bortle 6 sky at the very best. It's not as good as Stargate. That was taken with a 8-inch Schmidt-Cassegrain with a hyperstar, which is a device that replaces the secondary mirror on that telescope with an optic, and the camera plugs into the front of the telescope. So it gives you a telescope that's f1.9 f-stop. So it's very, very fast and a slightly wider field of view. So that to me just boggles my mind. You can get that from a light polluted area. That is that was a 3-minute exposure taken a whole bunch of times. I did it 2 hours and 3-minute exposure, 3-minute exposure over and over and over again. Then you stack them all. When you do that, it gives you all the it removes the noise and gives you a lot more detail and everything. To me, that's just phenomenal. I've got another picture was done with a 14-inch astrograph by a friend of mine back about 15 years ago, and from a very, very dark sky. And this actually is a better image. 8-inch telescope from my backyard. That just boggles my mind. So this is my Valentine's Day picture for you guys. I sent it to him also. Next time. Okay. That was Bob Vernon. Thanks, Bob. Anybody else? You're not getting up to show me anything.
Yeah, I can show something.
What? Oh, cool.
Let's
I
see
need
here.
to allow you to share.
Yeah, I got to share here. Hang on a second.
Can you share?
I'm on my laptop because Zoom doesn't work on my big machine. So give me a second here. There we go. Share screen. And I'll share that one. Let's share. Can you see that?
Yeah, that's nice.
Okay, that was taken last night out here at my observatory with my 10-inch RC. It's a little over 9 hours of data, so it ran all night while I was sleeping. And I processed it this morning, but it worked out pretty good. I was kind of pretty happy with what I got out of it here. So that was the first time I had the observatory open since November. So my wife shamed me into going out and doing something. Anyhow, so that's what I've got. Let's see.
Very nice.
Stop sharing here. Okay.
Okay, thank you.
Oh, and that's just to give some information, like that was 111 5-minute exposures from my backyard out here in the country of Bortle 5 conditions between Brighton and Fenton.
All right. Well, unless nobody has any other astrophotos, we can have Gary do his short presentation.
Before here.
Oh, but wait.
Yeah. Bob got us a new Night Sky Network account. Sure.
Yeah.
It's for the club. So we're trying to get that, but if you remember in years past, there was like awards and pins for our outreach people. So we're gonna try to do that again this year. So that's why you got to submit your reports to me, and then I'll decide what is the criterion for awardness.
The criteria is they just want you to submit things. And well, what I was doing, I still have those awards from 2019. I have to pass out. I'm embarrassed to say, but pretty much all I did was if you did something outreach, you got one. So
Okay. For our short presentation tonight, like that. For our short presentation tonight, we have Dr. Gary Ross. He's been a part of the Warren Astronomical Society since 1962. Not a member that long, but a part of it. He has in the past served as the president of the society, a prolific astronomy observer with outrageous claims about being the greatest of them in Michigan. He is defending his outrageous claim at this moment from the audience. He seems to be most comfortable with small, primitive refractor telescopes. And it would appear that electronics is not his forte. He was recently awarded an honorary doctorate in astronomy and oratorical arts from this society at our annual meeting. Tonight, his topic sounds rather cryptic or esoteric. The problem of TZ Arietis, or however you say it, I don't know what kind of problems that object is causing, but Garrett will come and tell us. The best of times and the worst of times. If our learned colleague over there can take from, I think, Walt Whitman, I can take from Charles Dickens. Well, here we are in Zoom land and in virtual land. Yes. You might remember my style from the heroic era. The evidence table, and transparencies, right? Everything black on white, big block letters, some of them hand done. No blizzard of information on my transparencies. No scrunched up 5-color graphs that one could not read beyond the 4th row. Remember those days? They're gone through no fault of mine. Now, you see, I used to be like Elmer Gantry, although not as good looking as Burt Lancaster. Once I was. Just give me a flatbed truck under a shade tree. Give me a windblown tent and I'll preach the gospel. I'll preach the word. Not some televangelist sitting there after visiting his hairdresser. No. But now we live in marvelous times. We do things on Zoom and virtually. Yes. Homo virtualis. virtual man. Divergent evolution is begun. Yes, not in this room, but out there in the big world. So I send my greeting to all our watching public in Finland, Uruguay, Ecorse, Lathrop Village, and other exotic places. I miss the evidence table and the overhead transparencies, and so all should you. This is a cramped style, but I overlook it. Notice how good natured. Where was I? Oh, yes. T.Z. Arietis. Right. This has been my undoing. This has been my debacle. My name is now trampled in variable star circles because of T.Z. Arietis, and I've come here to confess. This is like an AA meeting. No, my name is Gary, and I have a problem. Well, I certainly do have a problem, and I've come to share it with the real audience, not the virtual. Right? Divergent evolution. Homo virtualis. The first step toward the Eloi predicted in the 1890s by Herbert George Wells.
Did you just
I wondered when one of you stumblebums would catch on. Yes, I have broken a taboo. I have shown myself to be a mountebank, but you have to understand, T.Z. Arietis has made me kind of come apart of late, right? So nice going. Nice maneuvering, Sergeant. You got me. See, that's why I keep him around. Because he has it up here. He has it up here. So did I. I used to be pretty smart. And I didn't care who knew it. I'm not smart anymore. T.Z. Arietis is listed amongst other Jews. This is the 2021 version of the Observer's Handbook, the book of what is not here is nowhere. This is one of the greatest periodicals in the English language on science. Can be very inspiring. And in a way was my undoing. My little bighorn. There is a continuing article in the Observer's Handbook on the nearest stars. And in 2021, early 2022, I was perusing this, probably abusing the coffee refill in some bagel joint or coffee shop. And the eye fell upon the bottom of the page on the nearest stars article about T.Z. Arietis, the star T.Z. in Aries, the ram. What? Oh, I'm blocking the camera. Well, fancy that. These people in the Cranbrook Institute of Science can see me, and they're the ones who matter. They are Homo sapiens. Homo sapiens sapiens, not Homo virtualis. As I was saying, before I was rightfully interrupted, all right, thanks for pointing that out. All right, I will be more careful. Oh, see my arm? See? You know, it wasn't like this in the old days. I was marching back and forth, haranguing the crowd like Mussolini on a good day, right? I just had the whole room in the palm of my hand, and now I'm a cigar store Indian because of Homo virtualis. Now let's get down to business. I lost my train of thought again. All right. T.Z. Arietis
is the 37th closest star system to the sun. It is class M4, lowercase e, showing emissions, and it is variable. V, capital V, has delineated. According to Mark John Christensen, my old astronomy amigo out in Illinois, done some research for me, and he just tucks into anything without being asked. I don't know about this. This is coming from Dr. Christensen. There are 2 planets, and that those 2 planets are not delineated in the 2021 Observer's Handbook. So he's looking at some very recent data. It is indicated as variable, 14, by the way, 14.6 or 8 light years away. Now, those facts of the case are interesting, but not material necessarily to what I have to say here tonight. But when has that stopped me before? So now you know about TZ Arietis, which is a closed system, and it is class M4, it's pretty red, and shows emission lines in its spectrum. And according to Mark John, which is a pretty good source, it has 2 planets very recently discovered, I guess. So, duly inspired by the Observer's Handbook, the book of all knowledge, I decided to observe TZ. Even though the magnitude, remember, it has a big V by it, the magnitude is listed in the 12s. So I thought the 12s, I can reach that in the 6-inch Newtonian my dad and I built when Eisenhower was president, and is still, by the way, in use. So I made my first attempt to observe TZ Arietis at a star party, which God has forbidden me to mention. And I took a score, as they would say in statistics. Then things got interesting. I started to read the fine print. Famous last words from more than one farmer who's taken out a 3rd mortgage on his farm. And at the masthead of the star charts issued by the Association of Variable Star Observers, citation omitted, are the interesting data. Approximately magnitude 14 to approximately magnitude 15. The range of the variation. So I'm thinking, something's screwy here. This book says in the 12s. The Venerable Association of Variable Star Observers, operating out of Cambridge, not England, but Massachusetts, a worldwide organization, despite its name, says that it is a variable star that is really red, even by the use of the mighty Bohr 2 telescope in the Wien Observatory, to which I have frequent access. What then transpired was a series of observations. The first observation I made was in the summer of 2022, and observations continued into last year, not by everybody, but just by me. It is worth noting that a certain observer submitted 2 observations of TZ. I do not know where he, she is located, both in January. Confusion, discouragement, despair, suicidal thoughts started to appear. All right, this is from the once award-winning WASP newsletter, and it shall be again after the revolution. So what do we have here? My notes from 2022 submitted to Monsieur Timi. 5 through 6 August 2022. The problem of TZ Arietis in some high magnitude and very high elevation in turbid sky, impossible to see, extremely close to field star. Now, in the old days, comrades, I would have had the opportunity, analog style, to project the AVSO field charts on the big screen, black on white, high magnification. But we don't do that anymore. I'm looking at a chart and I am thinking that the star is not where the chart says it is because the data don't match. And I'm scratching my head and I'm thinking, oh, TZ Arietis is a 14th, 15th magnitude star sitting practically smack dab on a 12 point something comparison star. In other words, there are two objects, so we just pile on the magnification, which I did at the 16-inch Bohr telescope, working in 340, 360 power on that instrument. All right. Later in August, TZ Arietis, reprise of earlier observations, very difficult variable star, 12th magnitude. Field star superimposed, bright, given the target star, the variable star. Transparency, fair seeing good. Yeah, we're using, at this point, 225 power, merely 225. 23 to 24 August 2022. Problem of TZ Arietis. The variable star, extremely faint and superimposed on a much brighter field star object, might require bigger instrument under perfect seeing, unusual at low elevation, true, quote, challenge object. (2023) 12 to 13 September. TZ Arietis, TZ difficult field, faint variable with small amplitude, below 14.5. That's the figure that I put on my report to Cambridge. Below 14.5 magnitude. Like Napoleon advancing on Moscow. This one's going to be easy. Pardon me?
Can I ask a question, please?
Lay it on me.
In all your difficulties, and I admire your perseverance.
Uh-oh, now I know I'm really going to get it. All right. Yeah. Let's take a journalist saying, I have to ask this. Go ahead. Oh, yeah, you're mighty smart. Oh, all right. She is saying with great prescience and perspicacity that I'm out there hanging it over the edge, talking about 14th magnitude stars, and everybody else is saying it's around 12. You got that right. You know, I just look intelligent. Well, fairly. But the story's not over. I'm speaking to your point, by the way, Meta. All right. 12 to 13 September 2023, TZ difficult field, faint variable star with small amplitude below 14.5. Already read that. Commentary. Reported previously different ranges for TZ, Association of Variable Star Observers versus Observer's Handbook. Above observation, probably 12.6, the 12.6 comparison star on top of the variable star, even on the E-scale plot. There are different scales to the variable star charts. E-scale is small scale, very small scale. Association chart cites brightness far below the comp star, approximately 14.5 to 15, but the source mistakenly lists the 12.6 star given very close proximity. Only larger telescopes in excellent conditions could resolve answer. Additionally, likely position error for a 13.9 comparison star. I'm on a roll, right? I'm the man who's got all the facts. Look upon me and tremble, like Ozymandias. Keats, I think it was Keats. Cal Shelley, yeah, one of them guys. Yeah. 7 to 8 December. Time is short. All right. Then let's cut short the Dolorosa. Right. Put it this way: you see this trail of tears here, right? As I'm reporting to Cambridge, I am popping off in the WASP. So 13 December, handsome Joe McBride sending 3 pictures from Palomar Sky Survey in red, blue, and infrared. He sent this to me over the wire. I have taken the liberty to re-download the Palomar Sky Survey in red, okay, IR blue, and align it with the star charts, variable star charts. There's a slight misplacement from the sky survey to the chart from the o'clock position we observed. And that's because it's a close system and it's moving fairly fast against the venerable Palomar Sky Survey. And the Association of Variable Star Observers has got the more correct recent position. Quote, the star is classified as both a UVC-type flare star and a BY Draconis large spotted types, while UVC-type can cause the brightness to flare up several magnitudes. The BY Draconis type does not vary by over 0.5 magnitude. Quote, this is coming from Handsome Joe. It's a haymaker. I think any reported magnitude estimate dimmer than 13.0 would be highly suspect. So I submitted 5 line items on 30 July 22, 6 August of last year, 22 August, 24 August, and 3 September 23. I had to send an email to the Chief Technical Scientific Officer, Elizabeth O. Wagon, at headquarters in Cambridge. She is the Catherine the Great of the Variable Star Association, the equivalent of the immortal Margaret O. Mayall. And the header on my emails was, and by the way, I have a reputation in Cambridge, you should know. And now it is a reputation that will last forever. The header on my email was, I have been sending you rubbish. She was chivalrous enough to write back this morning and said, we will duly eliminate your observations from the roster. Because, as the comrade said back there, yes, everybody else is reporting a star in the 12s, and I'm reporting the star is below 15, below 14.5, because I'm confused by the chart. There is no superimposition of a comparison star over the variable star. That is the variable star. But damn it, when you look at the masthead On the field chart, it's got this business about 14 to 15. Now, I'm going to be nice. I should be. The AVSO is a venerable organization. They have a lot on their plate. Constant revisions, new stars in the lineup, in the car. And they can't get everything right. I'm aware of that. But I charged into battle thinking that I know my instruments, and by Christ, I know my variable star observations, having done it since the second Johnson administration, and I made a fool of myself. So that's the problem of TZ Arietis. Cut me and I bleed, right? This unworthy play for you, sir.
But now, is there a follow-up? Because really what's happened is you verified their mistake. So they still have a correction because they have it in their books as being 14 to 15, yes.
Yes, you have a steel trap. But you see, I have a political problem. I'm no longer a member. I'm some bloke in the countryside with a big telescope, which, by the way, is not mine, belongs to the association. Yeah, and I hope Comrade Wagen takes a look at that, or one of her subordinates. I'm sure that she has this bevy of graduate students or working under her to take a look at that chart and reissue it. Because if I had my overhead projector, I would show you the masthead with the false sponsor on it. But I'm not blaming them, because there is a lot going on in that organization. I remember it back in the Margaret Mayall when it was still pretty humble. So they can't get everything right. And but the case in chief is my error in basically looking at a chart wrong and saying, well, if there's this hash mark in the center of the chart that says 12 something, then this mysterious faint variable star has got to be right next to it. And you got to pull it out with high magnification and good seeing. No, there is no other star.
A complete figment?
Complete figment in this carbon-based unit. I do not like all the silicon stuff. It makes me nervous. One of these days, they're going to knock those silicon-based organisms back before they get ideas. I'm looking forward to it. All right. That's it. Yeah.
That's some quick question. All right.
Sorry. Okay. We have another question. Two.
Oh, that was commenting in my spot group. So
You're commenting on your sunspot? No. That hand back there. All right. I want that hand back there. I don't want your sunspot group. The rain in Spain stays mainly in the plain.
I think what you're saying is that the lesson to be drawn here is the same that we could draw from Solomon in the book of Proverbs.
Well, I'm supposed to be Elmer Gantry, naturally.
And a body spirit before a fall.
Yeah, God himself couldn't sink this ship. Cognitive dissonance destroys the proud man. Right. Well, say that again.
Pride goes before destruction and a haughty spirit before the fall.
Yep, that's me.
thank you, Gary. All right, we are taking our snack break. Reconvene at 20 minutes after 8 o'clock, 8:20. So go get yourself a munchie, cup of coffee, soda. We're having a snack break here. See you in a few. Okay, start getting ready. 1 minute warning.
I already gave 1 minute warning.
I was doing that for the benefit of the homo zoomus or whatever the hell Gary was calling them.
Homo virtuoso.
Homo virtuoso, homo virtuoso.
Virtualis.
Homo virtualis. All right. Who's in the chat? Okay.
The audio's fine now, though.
Where you get into your presentation?
What's that? Oh, nuts. How do I make the Zoom people go away?
No, I saw something pop up on the top of that window. She wants that Zoom window to go away.
Yeah. Can we make the Zoom people go away?
Yeah. I can't see your mouse. For some
No,
reason.
it's
No, just, yeah, click on this.
it's not a touch screen.
No, but I was just like showing you, like, click on the minimizer
I
thingy.
would like to, but
Okay.
There we go. All right. Thank you so much.
As usual, good thing you were here.
Thank you.
All right. All right, so welcome back. We are getting started again here. I have to take your seats, please. I can't do that.
Whistle.
Yeah. Miss Brian. We need a sergeant at arms to bang on something again. A gavel. That works. Have a seat. All right, so we're gonna welcome back. This is the Warren Astronomical Society. We are starting our main presentation, and here's our first vice president, Dale Parton, who will be announcing our speaker.
You need to mute that one.
That one. Wow. We just had a speaker who was a president previously of this August Society. Now we have another one. Diane Hall has been president of the society also. But there's another similarity of these two speakers. They both enjoy using vocabulary beyond my knowledge.
Oh, I don't believe.
Diane had the temerity to write. She has the temerity. My vocabulary is getting stretched here. To write that she is the quondam movie reviewer for the WASP. Now I ask you, how many people here, by show of hands, know what the word quondam means? Well, you don't count. She's the quondam movie reviewer for the WASP. No, I had to, no. I checked the definition. I had to look it up. Quondam. Quondam.
I stumped you?
Never heard of it.
Even Gary Ross is stumped. That's quite an accomplishment. It means she is the sometime or once upon a time movie reviewer for the WASP. She also among her other many accomplishments, is a lover of space shuttles and the people who flew them, especially to the moon, and historic observatories, and also a binocular enthusiast. She and her lifelong observing partner, Jonathan Kade, who's sitting back there with some library books that need to be dispersed tonight, look forward to spending more time with the 24-inch Causland Reflector beneath the dark skies of Alcona County, where they often go. Her presentation tonight is called Deep Impacts, and I hope she doesn't mean deep impacts on me. Diane.
Thank you, Dale. Hello, everybody. I read a lot of mid-century British history books, and it shows. All right, so tonight we're doing a presentation that touches upon things near and dear to my heart, and that includes Apollo moon missions, astronomy tourism, and astronomy-themed jewelry. And we'll see how that all plays into the craters that shape our lives and our landscapes. So, the classic image of a crater is, of course, this guy here. Meteor crater, more properly known as Barringer Crater in Arizona, here in the US. It's the best preserved impact site in the world. It's out in the desert, plainly obvious, not inhabited, and therefore it's not what we're talking about tonight, except in its role as a research site. Also not of discussion tonight, Manicouagan, aka the Eye of Quebec, seen there in winter and summer, and Wolf Creek in Australia. Again, classic craters, absolutely stunning, not what we're interested in tonight. We're going here to start off with. Fort, South Africa. Oh, lower the lights? Very good. So Fort is the second oldest impact crater known to us, and it's the largest extant. So we're going back in time to the Paleo-Proterozoic. This artist's rendering of the continents looks completely foreign to us. This is the late Triassian or the early Orosirian. And if these words don't mean anything to you, we have no cause to think about them unless we're planetary geologists. The continents are unrecognizable. This is 2.023 billion years ago. And the Earth suffered quite a few bombardments back then. And one of them just so happened to strike one of these blips of land in the water world. It was a bolide. The most recent estimates say that it was between 20 and 25 kilometers in diameter. I'm using metric in this presentation. Be warned, Imperial System aficionados. And impacted with a vertical velocity of 15 to 25 kilometers per second. So again, think on a scale of billions. Here is where the crater is. Here's evidence of bacterial life. Here's hard-bodied multicellular animals. And over here is a better known ancient continent, Gondwana. So no dinosaurs, no Pangea. We're talking microbes. We're talking nothing like we consider the ancient world to be like. And into that, bam. So what happens? Well, what happens when a body of that size and that velocity smacks into solid ground? You have the melt, you have the impact, you have layers depressed, and you have this up-faulted dome in the center, like exactly like the little blip at the center of a water droplet hitting the surface. Yes, sir. Thank you. And we have a debris field. Debris from this, again, this is South Africa in the present day, has been found in Karelia, Russia. Now, there's a trick to that. Karelia, Russia was a lot closer to what became South Africa back in the day. Do not think of it in terms of debris from South Africa arcing across the Eastern Hemisphere and ending up near the Arctic Circle. So, Frida Fort has a multi-ringed structure. That is a rarity on Earth. Why? Because we have two things that many other worlds do not. We have plate tectonics and we have erosion because of our weather systems, our water, our wind, our storms, all that good stuff. The moon has several multi-ringed structures that are evident, but probably the best known is this one from Jupiter's moon, Callisto. Callisto is a beautifully preserved frozen world covered in craters, and the Valhalla Basin gives you an idea of what the Frida Fort structure would have been like in the absence of erosion. So today, Frida Fort is located inside South Africa. You can see the dome and the massive ring, again, 300 kilometers. 4 towns exist in the vicinity of the dome, including its namesake. The word means peace fort. So people live there just going about their lives. You can see in this a lovely picture of the River Vaal Valley, very pastoral, very pretty. It's basically an agricultural, it's a farming town. There's some tourism, but just nice. But there is a secret to this beautiful pastoral landscape where, if you like to, you can tune into dome radio, celebrating the dome there in the middle of it all. Gold. So unraveling this landscape goes hand in hand with understanding why South Africa became a major producer of gold. Gold was discovered in 1886. And the fields exist in a crescent moon arc around the dome. Even after a century of mining, South Africa contains massive gold reserves. Estimates are that they only uncovered about half of what's in there. Shockingly deep. We're talking 4 kilometers below the surface and more, with some of the deepest mines active on planet Earth. So what's the relationship between this impact 2 billion years ago and the gold in the hills? Well, anybody think the gold was caused by the impact? No. It was preserved by the impact. It was buried by the catastrophic folding and slanting and burying of the Earth, like here, that it was effectively preserved for 2 billion years. No erosion, no ancient civilizations coming across it. It wasn't until modern prospectors, modern tools, modern technology, capable of going down 4 kilometers under the surface, that gold was accessible. So the meteor hid the gold until the modern era was ready to discover it, which is a little bit twisted, and lucky them. Now, you might say, okay, it's a crater. This was 2 billion years ago. There's no sign of any impactor. How do we know this isn't a massive volcanic thing like, the Yellowstone supervolcano, except extinct? How do we know for sure? Well, geology is our friend, and we've got some really nice clues. Numero uno, shatter cones. Anybody heard of shatter cones? All right, good for you. Did you get it from Barringer Crater?
No, I was given to me by the guy that did the meteorite lab, so I don't know where it came from.
Awesome. Okay, so shatter cones are rare geological features. They are only known to form in 2 situations: an impact crater from a meteorite or some other object from space, underground nuclear explosions. So if you can rule out that anybody was doing underground nuclear tests 2 billion years ago, which we have we can rule that out. We can do a different kind of science and we can rule that one out. It was a meteor. End of story. So there's evidence that the rock has been subjected to a shock with pressures in the range of 2 to 30 gigapascals. And if you don't know what a pascal is, that's a lot. So their presence it's a meteor strike. So this particular shatter cone comes from Reese Crater, which we'll discuss in a few. Second one, breccia. I want to say breccia, but in English it's breccia. Okay, it's Italian for rubble. So breccia is a rock composed of fragments of other rock in a fine matrix. And you can see that in the sample here, which was picked up by my beloved Apollo 16 mission. Thank you, John Young and Shirley Duke, for bringing these rocks back. Now, breccia is caused by many different things. So it can be sedimentary, tectonic, igneous, hydrothermal, or impact. And if you're familiar with rock collecting, you might think, well, what's the difference between a breccia and a conglomerate? I've got conglomerates in my mineral box. Conglomerates have been rounded. Breccia are sharp. Something bad happened to these rocks, and then there was no gentle weathering, no caress of the waves to make them anything other than just nasty jumble. How do you tell that it's an impact then if a breccia can be caused by many other things? Same way we determine a lot of things in archaeology, paleontology, history in general, and geology context. An impact breccia has friends. The friends are shatter cones, shocked minerals, and impact glass. So shocked quartz, that's clue number 3. Shocked quartz was not known to science until underground nuclear weapons testing took place. So it looks like quartz, all right? Quartz, one of the most common minerals out there in the world, silica dioxide. Well, this form of quartz is a microscopic structure. So you put it under a microscope and you see this stuff. It's different. Nobody had noticed it prior to nuclear tests. So the crystalline structure is deformed along planes inside the crystal. These planes show up as PDFs, which does not mean any sort of file format. It's planar deformation features. And a guy that you may have heard of, one Eugene Shoemaker, demonstrated that in addition to being an artifact of nuclear weapons testing, it was found at the best known crater on planet Earth, Barringer Crater in Arizona. Barringer Crater is like the mother lode of crater research. Why? It's there, it's preserved, no arguments about what it is, and it's in the US, so we can like send our NASA era scientists out there to do all kinds of cool stuff with it. Very lucky country with fabulous resources. Then we've got coesite. Again, it's silicon dioxide, kind of like quartz, but it's not quartz. It's quartz that bad things have happened to. In this case, high pressures of 2 to 3 gigapascals and moderately high temperatures. We're talking 700 degrees Celsius. So not surface of the sun hot, but more like surface of Mercury in the daylight hot. And it's different. Eugene Shoemaker figured this one out, and so did his collaborator, one Mr. Edward C.T. Chow. And we'll be hearing a little bit more about those guys later. This became the evidence that, yes, Barringer Crater was caused by a thing from space that whacked the Earth. And once Barringer Crater was unraveled, a whole lot happened in the field of crater geology. Then we've got something else that is kind of cool. Tektites. Anybody know what tektites are? They're glass. I have several examples on me tonight on my jewelry. Now, when I was a child, tektites were an object that was hotly debated. Are they meteorites or are they something else? I was about 6 years old and did not understand this particular conundrum because they looked like meteorites. What else would they be? Well, some people are still they came from space camp, but the majority opinion is that they are not extraterrestrial in origin, but are caused by an event of extraterrestrial origin. Long story short, thing whacks Earth, Earth melts, Earth goes splat, stuff cools, often hundreds, if not thousands of miles from where the impact happened. It's glass. Now, how do we know, again, that this is not volcanic in origin? Well, we melt it. And if you melt volcanic glass, it releases water and volatile compounds. If you melt a tektite, it doesn't, because all of that already melted and vaporized at the time of impact. So chemically, very, very distinct, and often can be incredibly pretty. Those of you with people in your lives who like jewelry, take note, moldavite, good stuff. Okay, so Fridafort, definitely an impact site. Almost the oldest. There's one in Australia that's even older, definitely the largest. What else have we got? Well, also unfathomably old and very large is the Sudbury site in our neighboring Ontario. And like Fridafort and its gold, this 1.8 billion year old catastrophe has economic ramifications that we feel today. So you can see the elliptical basin here. And there's a suspiciously crater looking lake up there called Wanapete. The original size of the crater is obscured by erosion. In between 1.8 billion years ago and now, a couple of things happened. Ice Age, yeah, the landscape's been through a lot. Even today, though, it is the third largest crater extant. It may have been as large as Fridafort originally, probably in the 200-kilometer range. Now it's down to about 130 kilometers. That's still really big. And the impact sent material as far away as present-day Minnesota. So we're talking far side of Lake Huron, all the way across what became Lake Superior into Minnesota, keeping in mind Lake Superior didn't exist yet. Since this was the Paleoproterozoic era, we know of no mass extinctions linked to this one either. There's just nothing in the fossil record. Everything was bacteria. Okay, so if you look at the map, there's some interesting stuff here. Here's the town of Sudbury that gives the basin its name. Here's a mine, here's a mine, here's a mine. Mining, big deal. During the construction of the Canadian Pacific Railroad in 1883, only 3 years before gold was discovered in South Africa, blasting and excavation uncovered vast quantities of nickel copper ore in the Sudbury Basin. Like South Africa, Sudbury was blessed and cursed by this impact. In this case, the presence of the nickel copper ore is directly from the impact itself, in the sense that the impact punctured Earth's crust. That's granite bedrock, okay, Canadian shield. Punctured it, allowed the mantle to well up through the crust and fill the basin with melted rock. As the shock wave shattered the surrounding rocks, minerals from the melted rock infiltrated all the cracks, becoming veins of precious and highly sought after minerals. Again, buried until the modern era, when the construction of the railroad, they used a lot of dynamite, exposed it. The railroad then made it possible for all of that to be extracted and commodified and shipped all over the place at the same time that they were despoiling the forests. So environmental devastation followed the wake of this discovery, to the point the rocks in Sudbury have been discolored by sulfur dioxide and the metals released during the process. Now, all that extraction type stuff did provide the telltale evidence that Sudbury was an impact crater. And if we weren't sure, breccia, our good friend breccia, 7 meters thick, Minnesota. We've got really good evidence of that. This event would have buried what is now Michigan under its estimated 130 meters of junk. Why don't we see it? Ice Age. But you can find ejecta, stuff thrown out of the craters, just lying about on the surface in places like this is from a park near Thunder Bay, Ontario, which again is on the far western side of Lake Superior, directly across the Great Lakes Basin from the impact. Now, Sudbury was used as a geological training site for the crews of Apollo 15, 16, and 17. These are my guys, John Young, Charlie Duke. They are learning how to recognize a breccia. They were sent to the Descartes Highlands on Apollo 16 because it was believed that the Descartes Highlands might be conclusive proof of volcanic activity on the moon. Very exciting. Instead, because of their studies and their ability to recognize a breccia when they saw it, they broke the sad news to the scientists. It was all breccia, all impact, no volcanism, sorry. Yes. I just assumed it was protective gear. I don't know. There was no explanatory stuff in the article that I found these pictures on. It was just like, here's the guys doing their thing. It's like, cool, it's my guys. I love these guys.
Style of the time.
No, this is the style of the time. Look at these glasses, man.
I think it's the camera, they have a camera set up for the race port.
That makes sense. That makes sense. Yes.
While they were in Canada, did they learn how to say sorry?
Probably not. You've heard these guys talk. They are Southern. So one little tidbit about Sudbury before we move on is in 2014, it was announced that the impact may have been caused not by an asteroid, but by a comet filled with rocky asteroid pieces. I read the paper. I'm not convinced. It's compelling. I think we need a little bit more on this. If you're really interested, I can send you the links. It's like, that's cool and weird. And yeah, moving on. If you visit Sudbury today, which we have done, they have a very nice science museum, which is very expensive, and we didn't actually go in, but it's cool. It is now home to 166,004 people, give or take. It's expanded its economy to emerge as a major retail, health, and educational center for Northeastern Ontario. It is the home, the birthplace of the legendary Jeopardy presenter Alex Trebek. So you've all seen the products of Sudbury, even though you didn't know it. They have also done great strides in cleaning up after the mining. Now, the next site I think you've all heard of. Chicxulub, second largest impact site on Earth and arguably the most infamous. I think everybody in this room knows the story. For those of you who don't, refresher. Approximately 66 million years ago, C-type asteroid 10 kilometers across slammed into what is now the Yucatan Peninsula at 20 kilometers a second. That's bad. Causing a catastrophe that killed 75% of all life on Earth and ended the age of the dinosaurs. Thanks to the BBC for giving me the cheesiest picture I could have possibly found. Oh. They ran this. Yeah. So unlike the Frida Ford and Sudbury impacts, this time there were complex plants and animals. We had flowering trees. We had pterosaurs. This was not the worst mass extinction on record, but it's the most famous, the most photogenic, and yeah, actually quite bad. It's called the Cretaceous Paleogene event, previously known as the Cretaceous Tertiary or KT boundary event. Now, the story of the verification of this as a turning point in Earth's history, arguably the reason that we are all standing here today in this room as bipedal, featherless, mammalian creatures and not, super velociraptors. It's a long story and relevant to the craters. It was actually a journalist by the name of Carlos Byers, worked for the Houston Chronicle back when newspapers had staff that did like lots of really cool reporting. And he pieced together the geological evidence in the Yucatan from just stuff he was hearing and seeing in conferences he was covering. And he was the first guy to say, hey, this crater and this idea that this thing happened that took out the dinosaurs, are they related? And he wrote it up in an article in 1981. And yeah, all the pieces started coming together from all the different disciplines as people became aware of one another's work. Yay for journalism. So it's not that the crater was unknown. In 1978, a geophysicist working for Pemex, that's the national oil company for Mexico, located the underwater half of the crater, doing magnetometer readings. They were looking for oil, they found this. Pemex did not share their findings with scientists because they weren't in it for science, they were in it for oil. They didn't care about the science. And so the scientific community had to work off a different set of clues. These. Anybody know what these are called? Bingo, cenotes, sinkholes. So yes, yep, in limestone. We have sinkholes here in Michigan, actually up around Alpena, the Hillman area. There are some very nice ones, but these ones in this suspiciously regular arc meant a lot. So Eugene Shoemaker wasn't just a great scientist, he was a teacher, and he had taught one of his pupils, Adriana Ocampo, that near perfect circles were unlikely to have come about through any means other than stuff whacking the earth. And so she played a pivotal role in decoding the mystery of the perfect arc of sinkholes. So what the deal is, groundwater flows through the limestone of the Yucatan, headed north to the sea, hits the buried rim of the crater, and is deflected. So it flows out to the Gulf of Mexico, and the northern coastline of the peninsula overlaps the rim of the crater. And as all that is going down, the concentrated fluid flow starts poking holes through the limestone, forming cenotes, water-filled sinkholes. This arc centered on the town of Chicxulub Pueblo, which lent the impact site its name. And you say, okay, that's great. People live there. That's cute. It's a really small town. Why did they do that? The people who discovered this were a little bit mad at the resistance that they were getting from the scientific establishment. And so according to Glenn Penfield, he was the geophysicist working for Pemex who found the crater. They wanted to give it a name that would give the naysayers a really hard time every time they had to speak it aloud. Nobody said scientists weren't petty. Scientists are petty. They're human. Okay, so you too can visit Chicxulub Pueblo and its neighboring Chicxulub Puerto, which is where this cute dinosaur art is. They're pretty proud of their rolling things. Not a lot of people there. Various divergent etymologies. I thought the devil's flea was funny because it reminded me of the asteroid being the devil's flea, and seemed fitting in a weird way. If you go, check out those cenotes. They are beautiful. This is seriously bucket list stuff for me, diving or snorkeling in the incredible blue water of these limestone sinkholes. Now, on to something a little less apocalyptic. Nordlingen Reese. It's a crater. It's a absolutely picture postcard village. Yeah, so Nordlingen is one of the only 3 cities remaining in Germany with intact city walls. It is nestled inside of a crater, Ries crater, located in Bavaria. The impactor in this case, it was about 150 meters in diameter, so 1,000 times less than the ones that we've been talking about. Traveling over 70,000 kilometers an hour, struck during the Miocene era. It was once thought to be volcanic in origin because people didn't have a good understanding of how craters work. It's been inhabited by humans since the Mesolithic. And the people who decoded its mystery, Shoemaker and Schau. Those guys got around. So I found this really cool graphic on a German, come to our cool village and check out our stuff site. It's in German, but you can figure out what it's about. So it takes you from 35 milliseconds before the impact to 10 minutes after the impact. So you've got the main asteroid, and it's believed that it had a companion that caused a different crater named Steinheimer. That's been disputed. It's now thought Steinheimer might be much more recent. So we're not going into that, but you've got the main impact, the plume, the fractures, this, apocalypse. You've got the debris, the breccia, and then finally this ruined landscape into which millions of years later, people are living a really cute life. So, Shoemaker and Schau. This is Mr. Shoemaker. Some of you might know him on site. He has a good reason to be smiling because he found things out that other people miss. His key evidence was the presence of that mineral we talked about earlier, coesite, which in the case of Nordlingen is located in a different kind of rock called suovite. There's no quiz, don't worry about that. But it's only found in rocks that have been subjected to the shock pressures of a meteorite impact. So turns out the whole town was built of the meteoritic rock. This whole church with its tower, which is charmingly called the Daniel, that's all meteor rock. So when Shoemaker and his buddies showed up looking to do some research, that it's just there. Even weirder, all the stone buildings are packed with microdiamonds, an estimated 72,000 tons of microscopic diamonds packed into every brick, every stone block of this town. So it's been inhabited for a long time. Okay, in addition to microdiamonds, these are mine. Moldavite. Moldavite, all moldavite on Earth, the meteoritic impact glass found in Bavaria, Moravia, Austria, and Bohemia is believed to have been caused by this single impact. So if you chance across moldavite in a jewelry store, a gem and fossil show, a museum case, I'm sure they have some on display here, that's an artifact of Ries crater and nothing else. Now, off to the land down under. Australia boasts many extant craters. A lot of it is arid. It's a wonderful place to preserve craters. The oldest crater in existence is in Australia. The oldest rocks exposed in existence is in Australia. Wolf Creek, probably the most classically perfect and obvious crater besides Barringer Crater itself, Australia. Henbury Crater, it's not a lot to look at. So why are we talking about this? It carries a very special distinction that intrigues me as somebody with a hobby about reading of the importance of oral histories of Indigenous people. The meteor strike that formed Henbury was approximately 4,500 years ago. 4,000. not 40,000, not 4 million, not 4,000. Australia has been settled by its Aboriginal peoples for 65,000 years. They have really good oral history. Oral histories in indigenous peoples, whether among the Inuit or the people of the Pacific Northwest, the Tahitians, the Australian First Peoples, they have a lot to teach us. Because when you don't have writing and everything in your history, everything in your being, everything in your essence, your humanity is bound up in the oral word, you do a really good job of passing things on. So let's look at the history of Henbury. Given that it was recorded by people who didn't have a whole lot of respect for the indigenous guides, it's a little bit sketchy, but the essence is this. The craters were found in 1890s. Scientists didn't get a look at it until either 1921 or 1931. My sources are a little sketchy. It may have been two separate incidents. It may have been the same incident. It may have been two guides. It may have been one guide. But the point is, don't go there. Don't go to the depressions. Don't get close. Don't drink the water. There's a fire devil in there. He will fill you with iron. And my grandfather saw him. Keeping the bit about the grandfather out of it, Dwayne Hamaker, who is a researcher at the University of New South Wales, did some looking into this, and he believes that we have captured in the oral histories of the people who live in the Henbury area an actual verifiable cause and effect, meteorite hit, bad things happen. We know that this is a cursed place. Don't go there. And it may be the only example on Earth of such a telltale connection between this apocalyptic story and right there. No, those holes right there. Don't do it. Pretty cool. Henbury also originally had ejector rays, like the Mercury crater, Mars, the moon, beautiful ejector rays on other bodies. We don't really have any there. Henbury doesn't have them either because prospectors made off with it. It was iron, it was shiny, they took it all. So let's go to the other side of the world, Kali, Estonia. Looks like a sinkhole, actually. There's some lakes that look awfully like this up in northern Michigan. 7,500 years ago, about twice as old as Henbury. Estonia, Proto-Estonia, was very densely populated at the time of this. So that raised my interest, and I thought, well, what do the oral histories say of this impact? The island of Saaremaa is where this is located. Saaremaa had a lot of people at the time. Estonia is very close to Finland. The Finnish epic, the Kalevala, does contain some very evocative verses about big fires and wars of the gods and things like that you can look and go, hey, maybe this had something to do with that meteorite that hit. But unlike Henbury, there's no means of connecting anything that the Finnish bards were commemorating back to the actual site on Saaremaa. The other thing about Saaremaa is, given how densely populated it was at the time, it might have killed some people. This might have been a really body count. Basically, it would have been like dropping an atomic bomb on these people. So what remains today are 9 craters. The smallest is a mere 12 meters across. The largest is 110 meters, so pretty respectable. About 2,000 years ago, they surrounded it with a stone wall and lots and lots of animal bones have been found at the site, indicating it may have been a place of sacrifice. The most recent sacrifices date to the 16th century. Yes, Estonia was a Christian culture by then. No, animal sacrifice is not permitted by the local authorities, and I have questions. So, Cali is much easier to visit than Henbury, and they would love you to visit. So they have a museum, they have a tavern where you can unwind. The museum is free if you stay at the hotel. Just respect the sacred lake, so don't mess around, but they really would like you to come visit. And I am happy to take them up on that, Jonathan, just saying. Closer to home, we have a couple of unexpected crater communities here in the US. They may not have the charm of the old world's walled city of Nordlingen or the spectacular geography of the Yucatan, but you don't need a plane ticket or a passport to get there. Middlesbrough dates to the age of the great supercontinent Pangaea, which was when the Appalachians were formed. Keep in mind, the Appalachians are a shadow of their former self. They were incredible, imposing, towering mountains at this time. And yeah, that looks like a crater. Oops. So it's in pretty sad shape because various things happened in the North American continent since then. It's exposed, eroded, but we've got the shatter cones, we've got the planar deformation features, we've got the quartz grains, we've got the breccia. Up until 1966, when the shatter cones were identified, it was thought it might have been a volcanic structure. But nope, shatter cones don't lie. And even in its present state, it's 6 kilometers across, so that's not nothing. Middleborough is the largest city in Southeast Kentucky. If you are road tripping down parts south for the April eclipse, why don't you swing by and check it out on your way home? Just saying. Okay, they thought highly of themselves. Okay, it's not Athens. I guarantee it's not Athens. No, it's not even that. These are aspirational. Okay, they had brothels, or they had something shady going on in the 30s, but other than that, it's purely aspirational. Oh, that's Nordlingen. Yeah, that's Nordlingen. Okay, so even closer, within easy driving distance, Metro Detroit is Des Plaines, Illinois. That's a suburb of Chicago. This is a trail marker along the trail where the meteor crater is located, and you see that they're illustrating their own crater with a picture of Barringer Crater. They're not trying to fool you. That's what it looks like. It's buried. It's completely hidden. Here's I-294. It's Chicagoland. That's all it looks like to the eye. It's completely buried under glacial till. How did that happen? Ice age. We in Michigan are very familiar with glacial till because it scraped and shaped our peninsulas. And same thing happened in neighboring Illinois. So it was also thought to be a cryptovolcanic structure when it was first found, but it's got an upfaulted central portion. It's got shatter cones. It's an impact site. If you want to check it out, it's a mere 4 hours and 33 minutes from here, right here. The epicenter is where Dempster Street meets the I-294 tollway. Easy, right? I'm not making fun of it, honestly. Jonathan can attest. We went on a tour through the back streets of London looking for the Buried River Fleet, which is essentially an enclosed sewer these days. The idea of going to an intersection in Chicagoland, like this is an impact crater. I love this stuff. They also had the original McDonald's franchise. It's not there anymore, but they did. Now, this is a crater that sparked my interest in the topic. Jonathan's sister and brother-in-law moved to Virginia, so we went with the kiddos to a museum where I learned something about Chesapeake Bay that I had forgotten about. 53 miles across, 84 kilometers, one of the 10 largest craters extant, best preserved wet impact marine crater on Earth. Most Americans know its name without ever realizing it's a 35 million year old crater. Chesapeake Bay in its present form is the largest estuary system in the United States. Sorry, San Francisco. Known for its beauty and the sheer bounty of the fish and the crabs and the shellfish, really good, good eats. It's the drowned valley of the Susquehanna River, and the ice sheets of the last great ice age never got this far south. So it looks like plausible fjords. No, not fjords. Ice never got there. So let's take a little thought experiment back in time. Miocene, or Eocene, sorry. What's now Richmond, Virginia was a tropical rainforest. The present Tidewater area would have been coastal shallows teeming with life. And into this comes a bolide traveling at 17.8 kilometers a second, punching all the way into the basement rock, the granite underlying everything, fracturing down to 8 kilometers below the surface. The bolide is vaporized. The initial crater is a hole 40 kilometers across, and a tsunami goes from there to the Blue Ridge Mountains in Tennessee. When everything settles out, the walls cave in, increasing it from the 40-kilometer hole to a 85-kilometer basin. It's buried underneath the junk of its own breccia. And then again, it is an ocean. It remains an ocean. The water comes back. Layer upon layer of marine sediment piles up over it. And oil exploration, once again, does the science for us. Atlantic City, New Jersey, 1983. That's the least romantic sentence imaginable. A drilling core reveals an 8-inch layer of ejecta, including tektites and shocked quartz. Bingo, we got another impact crater. Additional oil exploration in 1993 reveals the full extent of this incredible feature. Chesapeake Bay has a tektite field. I had never heard of this before. Black and dark brown bediacites have been found in Texas, while Georgia yields green Georgiaites. Now that I know these exist, I want some. Now, what if I told you, after all this, after all these trips through time and geology and oil fields and whatnot, the landscape around us has been shaped by an impact event yet unproven? Pretty weird, right? Keep in mind how recent many of these craters were discovered. 1960s, 1970s, 1980s, 1990s. And what proved their existence? Byproducts of extractive industries and the amazing vortex of moonshot era scientific research. Conditions that either don't exist right here in Michigan or don't exist anywhere. Remember, we used to spend, what, 6% of the national budget on the moonshot program? Yeah, we don't do that anymore. What if evidence of a massive impact from 500 million years ago was just right there at the Michigan-Ontario boundary line, right at the bottom of Lake Huron, figuratively and literally? Have a look at this magnetic data from the 1975 and then 1981. See this guy right here? See this in the middle? What's that look like? Yeah, it sure does. Okay, that's cool. Why don't we know about this? Why doesn't it have a name beyond the Canadian American thing? Why have we not pinned this down in the 4 decades since 1981? So there was a paper that came out in 1990. There is a strong similarity between the profiles of the Can-Am structure, it sounds like a plane, and the Manicouagan impact crater. Hey, that's the Eye of Quebec. Coincidence between a magnetic and gravity signatures suggests a common source for both fields. smoking gun, right? Well, it's tantalizing, it's plausible. Planetary scientist Jay Milosh said in 1991, we'd expect more of these craters. We know of 6, we'd expect at least 100. They got to be out there somewhere. Even when you take into account plate tectonics, even when you take into account erosion, even when you take into account that we know very little about the depths of the ocean. They've got to exist. So was this part of the world blasted by a 3-mile wide object back in the Cambrian? So from this article in 1991, it was noted that drilling needed to be done to confirm the hypothesis. But there's this really grim sentence. The US scientific drilling program, however, has stalled in recent years. And the fledgling Canadian drilling program is just getting off the ground. There's no money in it. No, nobody with the equipment has the money to do a wild goose chase to go figure out what's here, north of Sarnia. The truth is out there. But, you know, anybody got a drill rig? Oil company connections? Yeah. Jonathan.
You know, Thomas Edison knew about
The anomaly?
it. Joe, well, Thomas Edison wrote to his father back in 1898. Father, we have to get you out of that hole of the Fort Huron. And that's what he meant, right?
No, he meant Port Huron was the pits and he couldn't wait to leave. Yeah. So that is a curated selection of some of my favorite craters, large and small, a few vacation destination ideas, and some gift ideas for your loved ones. Any questions? Yeah, can we, let's see, let's get these lights back up. There we go. Now I can see you. Laura.
Right around Fort Huron.
Allegedly.
Is there any history of bird viewers?
I don't think so. Again, this happened during the Cambrian. So a lot of evidence would have been scraped away during the Ice Age. There were no people. There was trilobites. You know, there's no any mass extinctions associated with it. I mean, this was a big impact. Over 3 miles is large. There's just, I couldn't find much beyond a handful of Canadian sources, all of which were as old as I am, really. Gary.
Near the Barringer Crater, is Canyon Diablo near there? Yes.
Yes.
All right. Now, you made this comment about the Australian law that don't go very many silver iron. Even as a boy, I remember reading about Canyon Diablo and thinking, well, would you know anybody how long ago the Barringer was formed? 50? Oh, well, I don't think that.
Yeah.
So.
That's the thing with Australia is we know that the first peoples were there 65,000 years ago. They would have seen a lot. And I didn't go into it because the scientific community treats it more speculative, but there are other impacts that have happened in Australia between 65,000 years ago and now that have similar stories of fire and devils and things like that. Henbury is tantalizing because, believe it or not, with what we currently are understanding about oral histories, 4,500 years is not implausible for the essence of something to be passed down when you have a community that the word is life. Whereas these older ones, I think it's tantalizing, but there's just like, we're not really comfortable saying that it was passed down for 30,000 years. It's a plausibility thing. Mike. Yes. It's a kilometer across, meteor crater, Barringer Crater. Yes. Half a mile. Wait, it's a kilometer, yeah. For those of you interested in chasing down any of my sources, so I've got found some really cool, there's some articles out there, still extant on the rotting internet, some really cool sites. Crater Explorer is a lovely maintained site that is a great way to kill some time. The Aboriginal astronomy was fascinating if you want to look into some of the other oral histories of other impact sites, including Wolf Creek. That's where you've got some really good information. And then impactcraters.us. I did go looking for it. Now, Jerry Kuchera, I did give a shout out to him on the slide. He brought up the possibility of the Canadian American anomaly years ago in a talk. Likewise, Dave Bailey brought up the Oxford impact site. I can find nothing on that. So I went looking, hoping that maybe something had happened in the interim that would allow me to talk about the Oxford impact site. So far, nothing, but I tried. And if you want to visit, they'd love to have you. You know, go to Sudbury, go to Nordlingen, Sarma, Middlesbrough, Des Plaines. You probably, you know, if you do choose to go out to Henbury, be respectful. It's not a place where people have the welcome mat out for you. But Chesapeake Bay, you know, great place to visit. Any other questions, comments, conspiracy theories, hate mail, anything? Jonathan. Absolutely. Yeah, meteorite man, absolutely. All right, thank you, everybody. Right. What? Oh, yeah, let's check. They're just thank yous. Thank you, everybody.
All right, so that wraps this meeting up. Our next meeting is next week at Macomb Community College, Thursday the 15th. Our next open house is Saturday, February 24th. We'll meet after this at the Red Coat Tavern on Woodbridge, north of 13 Mile.